Hi, good evening. It's Jim from maverickstar Observatory. We've covered a lot of ground over the last few weeks. We really have. We're going to just go over a few of those things that we've covered. And more than anything else, we've added more armour to our defence to knock off this stupidity that world governments are coming out with regards to man-made CO2 and global warming, hence climate change. So, we've been looking at the eccentricity. We know that this is responsible for the glacial periods, and they last 100,000 years. From the start of the eccentricity, it takes around 50,000 years to reach its maximum elliptical shape, and then another 50,000 years to return back to a more spherical orbitable pattern. What we have to remind ourselves is that at its minimum distance, where the circle seems more rounder than elliptic, those periods don't last too long. Those, unfortunately, are our interglacial periods, and those are also the times where the glaciers melt. And now we realise that we live in a world which is covered more by ice the majority of its time than not. A couple of questions that was asked was, does the Earth speed up? And I think it doesn't. I think it maintains its orbital speed. It's just that the elliptical shape or the eccentricity shape changes. So we're not actually travelling less distance, we're travelling the same amount of distance, only the orbitable shape has changed, and that's why our calendars probably doesn't need to be adjusted, as far as I'm aware. A few of you have asked the question, where does this lead us next? Well, before that, I just want to go back over some of the ground very briefly in the last few charts that we've been looking at, and then we'll begin to ask the question, what do we face next? And how soon can we expect all this to take place? Now, there are a couple of variables that are affecting climate right now. It's not just one thing. It's not just the fact that we are moving into an elliptical orbit, and it's not just the fact that we're in a grand solar minimum, and it's not just a fact that we are also in a rare Earth event. That one lasted the last time, or took place, should I say, the last time, 780,000 years. And of course we're talking about the magnetic pole reversal, because we're in all three of those at the moment. And I will tell you this, all three could easily accelerate another glacial period coming about, because when we have a grand solar minimum, the heliosphere shrinks on the solar system, and that allows more intergalactic radiation and outergalactic radiation inbound into our solar system, and therefore can interact with our upper atmosphere. We're also facing a magnetic pole reversal, which weakens the magnetosphere, which allows more of the standard radiation in than normal, let alone whilst at a time when we're going through a grand solar minimum. And then when we are beginning to travel further away from our sun in an elliptical orbit, we then have further cooling and less protection from the solar wind, because of the distance as it increases through that elliptical orbit. So all three will probably enable us to go through the next glacial period, or start the next glacial period, a lot quicker. But what question we need to ask is, how long, I suppose, and you want to know this answer, how long then can we estimate things could start really getting noticeably difficult for ordinary cities to maintain themselves and sustain the amount of people? Because that really is the critical question, isn't it? So a bit later on we're going to get involved in that, but before we do, we're going to have a look at those charts. I just want to say a big thank you to the 4 people that helped chip in a bit of funding for this observatory over the last few days. That last video we had 5,000 views, and out of the 5,000 only 4 could find themselves to bring themselves to the point where they would literally support what we do with a little bit of finance. 5,000 people and only 4 step up to that line. It's a poor show, and I think you'll agree with me. What it requires is people to make a bit more of an effort, because we're approaching times where we should be working closely with each other, especially with a little observatory like ours, because we will keep you informed, and we will set the record straight when it comes down to climate, what is the real causes of climate, and what we can do to avoid some awkward situations for ourselves and our loved ones in the not too distant future. We still are rapidly approaching a 40-degree mark with the magnetic North Pole, despite what we've covered already. We've cleanly opened up the arena now, with telling people that, and not just telling them, but showing them the evidence to support that CO2 man-made climate is nothing but a scam, that the world governments are hoping that they can continue to pull the wool over people's eyes and tax them for it. They're doing nothing but wax their own pockets rich at the cost of life to human beings. That's the bottom line. What we want to do here at the observatory is keep people informed as to what is happening and when it's happening, and give them some good predictions so that they know what they're looking at in terms of preparation. So, with saying that, there is a link down there if you want to help support what we do. And I always say this, there's a lot worse things you can do than support an observatory. So let's get into it. So what we're looking at here is the last 400,000 years. You can see the last 5 interglacial periods that we've been through, and the last 5 glacial periods that have lasted on average around 100,000 years. One thing that does seem to be happening is we seem to be, as time goes on, lasting longer in interglacial periods, but in general they're roughly spaced out around 100,000 years apart from each other. And what happens is, when we get to the outer regions of the elliptical orbit, as we travel around the sun during this period of time when the elliptics start to come into play, what happens is 50,000 years in, we reach the maximum elliptical shape that is halfway in between a glacial period, and then it is no wonder why we start to warm back up, because we start to, after 50,000 years, come back and the elliptic period starts to close, and that brings us out of the glacial period back into an interglacial period. But we don't spend much time there, as you know. As you can see from the last 5 interglacial periods, if we spend 12,000 to 15,000 years in an interglacial period, that's as long as what we do. The temperature difference between interglacial and glacial periods is around about 8 degrees Celsius, which is not a lot, is it? When you go negative 8 degrees Celsius, you're in the middle of an interglacial period, so you're at the outermost reach of that elliptical shape that we travel every 100 and so thousand years. So what this also shows, more than anything else, this particular chart, is that carbon's not responsible for creating global warming effects. Now, with what I've discussed in this video and the recent video, there is no way that anyone can ever come back from what we've presented here to say or support that CO2 causes climate change, in the fact that it heats up the Earth, because now we know what cools the Earth, and now what we know is what brings us out of the glacial period. It's just the position of where we are on that elliptical orbit that goes around the Sun. So 50,000 years in, we're at the most coldest part, and then 50,000 years from that point we start to gradually warm back up, and that's when we arrive at the closest spherical orbit around our Sun, and that is called a glacial period. They don't last long, as you would expect, because this is a cyclical event that happens every 100,000 years or so, and therefore it changes the climate according. The question that is on a lot of people's minds, and before I answer or begin to answer that, I don't think it's one that can be answered very easily, because the amount of anomalies now that are affecting climate on our planet, and by some synchronicity there is more than one, and I wouldn't have thought that these reoccur at these specific times. Normally it's just random anomalies that have all come together, and I think that the result of that will mean that we will go back through a glacial period much quicker. And I think that the one that really could do something about that is the fact that we're going through a magnetic pole reversal, and then just having the other two on the back of that just makes matters worse or compounds the effect. So that's what we're going to be looking at now. I wanted to just give you an idea of what's happened this year, just so you know. And I mean, this is another slap in the face for these proclaimed scientists that work for the government. You know, if ever you can hold your face now in public and keep a straight face, then you're a better actor than, I don't know, Tom Cruise. You must be, because you know the evidence is just massing now against them, and at some point they've got to come clean. I really feel in the back of my conscience that they know we're merging back into this difficult period of time. They've used global warming as a scapegoat, and they know that the Earth will not be able to sustain the amount of people that is on it right now. And you can check this through other websites, through other channels on YouTube. We are struggling to feed the 8 billion people on this planet right now. So, you know, in the coming years, in the coming decades and centuries, how the hell they are going to do it is beyond me. And I am giving you the heads up right now. I'm not saying move tomorrow, because I don't think that this will be a rapid shift. I think it could take a few years, at least a couple of years, before we start to see, you know, a brand new extended winter season that lasts a lot longer. And then eventually, the more ice and snow that build up over the northern hemisphere, it will become the norm not to have a normal summer where the ice and snow does not thaw. And at that point we get another effect happen, which compounds the effect of glaciation, and that is the fact that most of the northern hemisphere is covered in a white substance, i.e. snow and ice, and that is a perfect reflective substance, which will bounce back the radiation as soon as it comes in, which will keep it cooler until we eventually merge back closer to a position more spherical in our orbit, and hopefully, you know, at that time, I suppose things will be, I don't know, thinking about it now, we're talking so long into the future, it's really hard to comprehend what will be going on in this world in 100,000 years, and what we will even look like in the next 10,000 years, when we have really merged into some of the most harshest climates we've ever witnessed on the northern hemisphere. And this is why I'm saying to you guys, you do really have an opportunity here to take advantage of this before it becomes common knowledge, because if it does, people will be selling their properties above a 40-degree latitude quicker than anything else. Once this becomes common knowledge, there'll be no reason for people to settle over in the north unless they have got the opinion they want to become Eskimos. So let's have a look at what the temperature line looked like yesterday on the Earth. So we'll have a look at North School, and we'll just have a look at the W3 map, so that we can see all corners of our Earth laid out on the W3 map, and see what the temperature was looking like around 50 degrees. And you'll understand why I said, you know, you really need to be below, if you're in the northern hemisphere, 50 degrees latitude, or if you're in the southern hemisphere. And we're going to be talking about the southern hemisphere a lot more, because you guys unfortunately don't avoid this problem, because as the elliptic orbit becomes further extended away from the sun, well, your summers and winters are based on the same as what ours are, and that is just depending on which side of the sun and at what time of the year you're there, because your winters are equally going to get just as bad as ours in the northern hemisphere. So we'll have a look at that line then on the W3 map next. So this was a still that I took on North Score yesterday at the temperature on the planet yesterday morning. As you can see, most above the red line over the northern hemisphere and the southern hemisphere is sub-zero temperatures. That was taken yesterday, and that's why I say during the next glacial period, that's where you want to be below if you're in the northern hemisphere, that's where you want to be above if you're in the southern hemisphere. And you can see how much landmass it actually occupies. Now, one of the questions which might have gone through your head is, well, how much actually is an extra 2 million square kilometres in size of, continent? Can we make a comparison? Yeah, we can, and that's what we're going to do in the next slide. But you can see already that anything above that red line is mostly consumed with sub-zero temperatures in the northern and southern hemispheres, or below in the southern hemisphere in that case. And that's why I'm saying, those properties, those territories shouldn't really have been occupied, but yet we did 300 years ago, didn't we? We occupied the territory of Canada and mid-United States, as well as a lot of other countries that wasn't widely occupied. Now, most of our earlier descendants come from the Middle East. You know that, don't you? It's only recent 1,000, 2,000 years or 3,000 years that we started to merge into other regions and colonize other continents like America, Canada, etc. You're going to understand why there was never inhabited before there was in the not too distant future. That's because basically these are floodplains, and the reason why you don't build a house on a floodplain is because it generally floods, and it might not have flooded for 100 years, but that doesn't mean it's going to flood tomorrow. And we're seeing this happen all the time in many parts of the world where people are just naive and build their properties in these floodplains. They also build them in the volcanic paths of magma. We've got to wake up and understand that geology changes. It's us that has to be migrational in order to avoid these things. And if we just take a lesson from nature, as always we do get most of our technology, by the way, from a lot of different species and the way they behave. None of us would have Gore-Tex if we didn't understand certain plant species today. So again, we take some knowledge from migration in animal species. We understand that we shouldn't be bolting our cities down in fixation in some continents like we have done, because you are obliged then to try and keep it sustained. And as Canada is going to find out, I know they're only suffering with floods, and I know that majority of the time they do deal with a lot of harsh conditions. I'm just using it as an example, by the way. I'm not picking on Canada. There are European countries, there's Russia as well, Siberia. But what I'm saying is that the climate there generally is not in support of large number of people. And yet we've colonised it with millions, if not billions of people, these regions. And just like the Vikings found out in a very short period of time on Greenland that it can't be sustainable to stay there, the exact same thing is going to happen to those people in these regions very shortly. This is the Arctic sea ice extent chart. You can see that we've clearly put in 2 million square kilometres of extra ice just in 2021, which is more than what we did ever see since 2012 at this moment. And as you can see, it is merging ever closer to the 1972 to 2020 average line, right where we are right now in almost December. So this gives us an idea of how fast this Earth can put on that ice, but we need to put that into context. We need to understand how many, or how large is 2 square million kilometres. So I'm about to show you. and here you are. That circle that you see around the entire United Kingdom, Ireland, Scotland, England and Wales, and I could have easily positioned this circle over a lot of European countries. Just gives you an idea of what 2 million square kilometres looks like. Yep, it's large. Guys, there's a link down there if you want to help support what we do at the observatory. Hope you got something out of the video, and we'll be back in the next few days. As always, take care of your loved ones. I'll say what I usually do. Bye for now.